We all want AI agents to make our lives easier, right? But what happens when the very tools we build to help us end up becoming our biggest security risk? Today, we're diving into one of the most important battles for our AI-powered future, agent authorization, and why getting it right is absolutely critical.
Right now, we are stuck with what feels like an impossible choice. On one hand, we can build these incredibly powerful agents by giving them access to everything, all our apps, all our data, but that creates a massive, massive security hole. On the other hand, we can lock them down, make them super safe, but then they're so limited they're not even that useful. It's a real catch-22.
So, how do we get out of this mess? Well, here's how we're going to break it down. First, we'll look a little closer at the problem. Then, we'll get into a key part of the solution, a protocol called OAuth. After that, a fascinating real-world story will show you exactly why this is so important. And finally, we'll look at what's next for AI security. Okay, let's get right into it. The way we commonly connect agents to our systems today, frankly, it's a ticking time bomb. You've got developers copying and pasting these super long-lived, all-powerful API keys right into their code. Now, imagine doing that for hundreds, maybe thousands of agents. You're not just creating a risk, you're literally building a catastrophe waiting to happen. But here's the really wild part. We don't have to invent some brand new, complex solution to fix this. The answer's been around for years. We just need to stop using these static, permanent keys and switch to a system of dynamic, temporary access. And the way we do that is with a protocol called OAuth. So, what in the world is OAuth? You know, the official spec is, let's be honest, pretty dense. But the core idea is actually super simple. In fact, I bet you've used it dozens of times this week without even realizing it. At its heart, OAuth is a framework for what's called delegated authorization. It's just a secure way for one app to ask for permission to access your stuff in another app, and this is the key, without you ever handing over your password. It's all about you granting very specific permissions for a specific reason with your explicit okay. Just think about the last time you hooked up Calendly to your Google Calendar. That entire dance is OAuth. Calendly, the client, asks Google for access. Google, acting as the authorization server, pops up and asks you if that's cool. You click Allow, and Google hands Calendly a special temporary key, an access token that only works for reading your calendar. That's it. Your Google password is never, ever exposed. That Calendly example feels pretty straightforward, doesn't it? But the reason it's so secure is because there's a very careful separation of powers happening behind the scenes. And to really understand how this applies to our AI agents, we've got to break down the three distinct roles that make the whole thing work. You see, the real magic here is this separation of duties. You've got the client, that's the app asking for access. You have the resource server, that's the API guarding your data. And then you have the most important player, the authorization server. It's the trusted gatekeeper that handles consent and issues the keys. This is brilliant because it means the server holding your data doesn't have to worry about passwords at all. Its only job is to check if a key is valid. Now, this three-part structure might seem simple on paper, but it is incredibly easy to mess up. And a perfect real-world example just happened during the development of a new standard for AI agents called the ACAP. Their story is a fantastic lesson in what happens when you don't respect these roles. So the AACP protocol is brand new, and its rollout was, let's just say it was messy. The very first version had no security whatsoever. And then, when they tried to add it, they made one critical mistake that basically sent the entire security community into a frenzy. So what was this fatal flaw? They broke that golden rule of separating the roles. They tried to make the AACP server, the thing that holds the data, also be the authorization server, the thing that issues the security keys. They collapsed two distinct vital jobs into one, and that completely breaks the security model that makes OAuth work. And the community sighed immediately. Experts like Christian Posta started writing these blog posts that went viral, pointing out that, hey, mixing the resource and authorization servers is a fundamental misunderstanding of how this is all supposed to work. And here's the best part of the whole story. It worked. The public feedback, the outcry, it forced a change. The standard was corrected. The ASCP server was put back in its place with one simple job: be a resource server and just check the tokens. All the hard work of security and issuing keys was handed off to a separate, dedicated authorization server, exactly the way the protocol was designed.
Okay, so getting that connection right between an agent and a server is a huge win, a really big deal. But honestly, it's just scratching the surface. If we want to build a truly secure AI future, the really hard challenges are just getting started. And these challenges get really complex really fast. I mean, look at this list. We're talking about figuring out how agents can securely talk to other agents, how we can verify an agent is who it says it is, and how we can even know for sure which AI models our data is being sent to. These are the next big frontiers we have to conquer. Let's just zoom in on one of these for a second. Transactional authorization. The old way is giving broad permissions, right? Things like let this app read my calendar or write my emails. But for powerful AI agents, that's not good enough. We need to be way more specific. We need to authorize a single transaction. Like, okay, you can book a flight to San Francisco, but only if the price is under $500. Now that is the kind of fine-grained control we're going to need. And this is why that whole AACP story is so important. That public debate over a tiny technical detail wasn't just nerds arguing about code. It was about hammering out the foundation for our entire AI-driven future. Getting these protocols and standards right is the only way we can build agents that are both incredibly powerful and completely trustworthy. Because ultimately, the boring technical standards we're building today are what will define the limits of trust for the mind-blowing AI of tomorrow. And that leaves us with a huge question. As we let these agents act on our behalf, how are we going to prove who or what is actually responsible when something inevitably goes wrong? The answer is being written right now in the code of these protocols. Thanks for watching.